In an airplane, many tubes are needed to carry gasoline and oil. Each tube has its own definite place. This gasoline feed line or tube, for example, bends over, around, under, and between various parts, and must therefore be bent accurately. The tube could not be installed in one piece, so it is cut, bent, and installed in convenient lengths. Let's see just how this piece of tubing is bent. This model tube, or mock-up, serves as an exact guide for this job. A jig is made to fit the mock-up. Each tube that is bent must fit the jig. This job card gives the tube size, its length, gauge, and exact specification for each bend. The outside diameter called for is 5/8 of an inch, gauge 42 thousandths of an inch. Make certain that the tubing has an outside diameter of 5/8 of an inch. A tube micrometer is used for checking the gauge or wall thickness. The gauge is 42 thousandths. Check the length of the tube to see that it is long enough. The job card calls for a 1 1/2 inch radius block. Blocks of various sizes are usually stored in a cabinet under the bench. In selecting the correct block, check the radius, 1 1/2 inches. The 10 represents 10/16 or 5/8 of an inch, matching the outside diameter of the tube. Next, select a mandrel. The markings on the mandrel show that it is for a tube having a 5/8 inch outside diameter and a gauge of 42 thousandths. A clamp block having a groove the same size as the tube, number 10, is selected. A slide block, also having a number 10 groove, completes the parts necessary to be assembled onto the machine for this job. In bending a tube, the radius block controls the curve of the bend. The mandrel fits inside the tube. It prevents the tube from buckling or collapsing as it is bent. The clamp block holds the tube in a vise-like grip against the radius block. The slide block holds the tube against the radius block at the bending point. As the tube is bent around the radius block, it is drawn forward. The slide block slides forward with the tube. The mandrel remains at the point of the bend. All parts are carefully cleaned before being assembled. The longer side of the radius block must always face toward the side on which the tube will lie. To make certain that the mandrel is clean, rub lightly with steel wool and finish cleaning with a rag. Screw the mandrel all the way onto the mandrel rod. Adjust the position of the mandrel so that the line on the mandrel is 5/8 of an inch back of the mark on the radius block. To secure the mandrel in position, the mandrel rod is locked in place at the opposite end of the bench. The rod is set 1 1/2 inches off center to match the 1 1/2 inch radius block. Check to see that the mandrel has not moved. The machine is now ready for the tube. The first bend begins 8 inches from the end of the tube. A sharp, hard pencil is usually used for marking. A little oil brushed into the end of the tube opposite that which was marked allows the tube to be slipped easily over the mandrel. Since the pencil mark denotes the start of the bend, slide the tube along until it is opposite the mark on the radius block. To hold the tube in place against the radius block, the clamp block is now inserted. The number 10 groove must face the tube. Tighten it. To prevent the tube from slipping when it is pulled forward, insert the slide block and tighten it just enough to permit the block to slide as the tube is bent. Set the side angle indicator at 0 and fasten the tube. The machine is now ready for bending the tube. The angle of the first bend is 90 degrees. Note how the tube is pulled forward as it is bent around the radius block. An angle indicator tells how much the tube is bending. The slide block keeps the tube against the radius block. When the indicator reaches 90 degrees, check the tube for spring back. Although bent to 90 degrees in the machine, the tube springs back from the radius block when the clamp block is loosened. The amount of this spring back may be measured with a protractor. The reading on the scale is 87 degrees. Therefore, the spring back is 3 degrees. The tube is reclamped into the machine for further bending. To allow for this spring back, The tube is bent to 93 degrees, so it will spring back to 90 degrees. The bend is now complete. It may be further checked for accuracy in the jig. Replace the tube on the machine to make the second bend. The card shows 10 inches and a turn angle of 70 degrees. This means that the second bend begins 10 inches from the line that marks the start of the first bend. Clamp the tube firmly in the side angle indicator. With a flexible tape, measure the 10 inches from the first mark around the radius block. Mark the tube 10 inches from the first mark. The tube is released so that the machine may be set to make the turn angle for the next bend. The amount of rotation of the tube from its original position determines the turn angle or side angle. This is measured on the side angle indicator. Since the card called for a 70-degree turn angle, the side angle indicator is rotated to 70 degrees and locked in position. The tube has now been turned 70 degrees. Again, the pencil mark on the tube must fall opposite the mark on the radius block. Tighten the clamp block, then the slide block. The bend called for is 40 degrees. Since the bend is 40 degrees, the tube must be bent to 43 degrees to allow for the spring back of 3 degrees. This completes the bending. Check for accuracy on the jig. Compare it with the mock-up. The close fit of the tube on the jig shows that it has been bent accurately. This tube will fit into the final assembly. Accurate tube bending depends upon following the job card directions. Radius blocks, mandrel, clamp and slide blocks must fit the tube. Remember, allow for spring back. Check the angle indicator as the tube is bending. Careful and accurate work is the sign of a competent operator.